Yeah, maybe.
Not pattern.
Maybe. It's just that I'm not exposed to that one yet. Not yet. Okay, so let's dive into lesson 5, proving identities. Proving identities. Okay. We're going to try some of these first, this part, and then I'm going to give you a handout for us to try. So it says here, prove the following are identities and identify any non-permissible values. So, well, how do we prove that this is an identity? Okay. Now, we're not solving for x when there's a difference between solving for x and proving. So when we talk about proving, we're gonna just focus on one side. Okay, use some of our basic identities and identities that we know of to make sure that this left side is going to equal to the right side. Okay, so this left side is the cos x secant x, and the right side is equals to 1. Okay, if you didn't get one of these, so if you could just come up and get one of these things, we're going to use this right away.
No, I understand.
So, the ones that we know, well, actually, some of them are here. Some of the really, really basic ones are on your booklet, okay? So, we're going to work one side only and try to manipulate this so that it equals the other side. So, let's start with cos of x times secant of x. Okay. Well, cos of x is just cos of x. Is there another way that we can write secant of x? Okay. So yesterday we looked at the other identities. Secant, we said, is the reciprocal of cos. So it's 1 over cos of x. Now that we have that, we know that the cos of x and the cos of x, they're common factors. They can cancel out. We're left with 1. So the left side is equal to 1, and the right side is equal to 1. So therefore, left side is equals to the right side. Okay. So we're starting with the baby steps. I like baby steps. So far, so good?
When we cannot make this so Gabby part, this means?
Yeah. So that means any values that you put in here for x, it's going to always equal 1. I'm going to show you that they're equal to each other later. Okay? So remind me if I forget. I will show you a visual of this. Okay. Let's take a look at letter B. Tan of x times cos of x. So you get the left side, which is tan of x, cos of x, and equal to the, we have, why did I say sign? Right side. Okay. Sine of x on the right side. Okay. We're going to try to see if this is an identity. If tan of x times cos of x will give us sine of x. Let's try that. So tan of x times cos of x. Okay, what can we do as a possibility? How do we start?
Change the tan of x.
Yeah, change the tan of x to its identity. And what's the tan of x? Yeah, over cos of x, right? So sine of x over cos of x, and then times by cos of x. Okay. We can cancel common factor. Cos of x and cos of x are common factor. That can be. So that means we're left with sine of x. So that means left side is equals to the right side. Okay.
Is
Yeah.
that even, because it says to identify the non-permissible
Yeah,
value?
we're gonna do, yeah, I just realized I forgot to identify the non-permissible value. So let's take a look at this one and I'm gonna come back to this, okay. What's the non-permissible value here? Now, here it's kind of hard to figure out the non-permissible value because everything is in the numerator, right? So if we were to write sine of x divided by the cos of x times cos of x, what's in the denominator?
90 degrees and
Okay. What's, yeah, okay, you're already telling me the answer. What's in the denominator? Cos of x, right? So the non-permissible value here will happen when the denominator, which is cos of x, will equal to 0. So cos of x is equal to 0. Okay. Now the big question is, what are the x values, or where are the angles where cos is going to be 0? Cos is 0 at pi halves, and 3 pi halves, okay. So I'm going to have a visual in here. This is where the denominator will be 0 here at pi halves and 3 pi halves.
So pi halves plus 2 pi. Okay.
So this is the pi halves, and then this is the 3 pi halves. So we can write it down as pi halves plus 2 pi k, or 3 pi halves plus 2 pi k. Okay, so you is there another way of writing the same thing, but in a concise way?
The pi k?
Pi would be pi halves. So this is your starting point, and then you're turning over here. How many radians?
Pi.
Pi. So you can write both of these down. That will cover both of them, right? That's 1. So here's a more concise way. Oh, I gotta put where k is an element of integer. So let me fix that. So when you go back, where k is an element of an integer, k is an element of integer. So here's the solution there. Or here's a more concise way of saying this. We can say x is equals to pi halves, which is over here, and then to go to the 3 pi halves, you just go plus pi k, and then where k is an element of an integer, because every time you turn k amount, pi radians, you're gonna hit that.
And for our NPV, do we go cos is equal to 0 or not
Yeah.
equal?
Non-equal, cannot equal to. I think either way works as long as you say the non-permissible value.
Okay.
Yeah, so non-permissible values are these. Okay.
Can we say like pi half plus pi k? No, because half of that.
Yeah, that's this one.
Oh,
Yeah. Yeah. So you can say these two combine, right? This is a long way of writing the same thing. This is more of a concise. This is what you're asking about. Yeah, good job. Okay, now I'm gonna go back in here because we didn't talk about the non-permissible value here. So what's a non-permissible value here? We can't really figure it out from here because it seems like there's no denominator. But when we change the secant to 1 over cos, then we know that there's going to be a denominator that we can't have equaling to 0. So the non-permissible value, non-NPV, cos of x cannot equal to 0. Okay, so this is pretty much the same thing as what we had with b, where x is equals to pi halves plus pi k, where k is an element of the integer. So every time you see a pi half, and then you turn pi radians each time, you're going to get into those points where it's non-permissible. Okay, is that good? Let's take a look at this one. Letter C. Okay. We're going to first make the left side show that it's equal to the right side. Okay, so what's your strategy here?
Break it down.
Break it down, yeah. So secant x divided by cosecant x. What do we break it down?
1 over cos.
So secant of x is 1 over cos of x
And then over 1
divided
over
by 1 over sine of x. Okay, is everybody okay with that piece? Now, this becomes a complex fraction. That's the same thing as multiplying the reciprocal. So it becomes 1 over cos of x times multiplying the reciprocal. So it's going to be sine of x over cos of x. Oh, sorry, no. I'm already going ahead. Okay, so that becomes sine of x over cos of x. And we already know that that's one of our identity. When you see a sine of x divided by cos of x, that's equal to tangent of x. So our left side is now equal to our right side. Right? Tan of x. Now, non-permissible value. What do you think the non-permissible values are? So when we put it this way,
Or is it sine?
okay, now, when we look at this one here, cos of x is in the denominator. Where is the cos of x? 0, because this is the denominator. We don't want the denominator to be equal to 0.
Is it both K?
For sine, no, the sine could be okay. The sine.
Because like you're dividing the 1 and divided by the sine, so K.
Yeah.
Yeah, so it could be 0.
So in which form do we take the non-permissible value?
From this piece.
Oh, okay. Then
Yeah.
it goes.
And be cosine. So cosine of x cannot equal to 0. That's a non-permissible value. So x cannot equal to
By half.
pi half and
Pi k.
plus pi k. And k is an element of integer. Okay? The non-permissible value could be really complicated the more things that we add into it. Okay, now let's take a look at this one here. Which one can we work on?
The right side.
What's that? This one here? Yeah. So you're I think catching on in here. What's happening is that if you have something complex like these, change it to the ones that's simple. Right. So left side and right side. Okay, so the left side is just cos squared of x. Let's see this one. Cotangent of x times sine of x secant of x. Okay. So how do we work this out? Cotangent is
Cos over sine.
cos of x over sine of x times the sine of x divided by 1 over cos. Okay, so now we're going to have a complex fraction in here. The sine of x has a common factor that can be cancelled out. So we're going to get cos of x divided by 1 over cos of x. And if we do that, cos of x times the reciprocal. Cos of x over 1. So that makes it cos of x times cos of x. That's cos squared of x.
Do you have to cancel it right away, or could you see what it all is and flip it up right away and then do the cancellation?
Which one? This one?
Because you know it's going to be 1 over cos, so you
This
just
one over
flip
here.
that up
Mm-hmm.
right away and then just
Yeah,
cancel
you could do
them
that.
out?
Yeah.
Is that better?
So this one you can't cancel because they're not both in the denominator. Yeah.
I just mean, if you know what's in the denominator and you know how it's going to flip up
Mhm.
anyway.
Yeah. So you can go from here to there. Is that what you're saying? Yeah. Okay. What's the non-permissible values?
Sine.
Mm-hmm. Now here, the sine of x in this denominator, even though it's in the denominator, it's overall in the numerator. So, and this sine of x will cancel the sine of x there. Mhm. So it's going to be this one will make this denominator 0, so sine of x is going to give us 0. The cos of x is going to be, when we take the reciprocal of it, it becomes cos squared. It becomes part of the numerator. But then this one, cos of x, that's what also make it 0 within this category. Okay, so let's take a look. So sine of x is 0 at pi k, right? K is an element of integer. Okay.
So is it
Let's
two
see.
possibilities for that?
Let's take a look at the,
Because in the first example there, we had a cancellation.
yeah, let's take a look at the graph, and then let's see what kind of graph we're gonna see.
Do you think the sine of x will be the intercepts?
Hold on, okay?
And your computer's just gonna explode. Maybe the brackets are weirding it out. like that graph.
Doesn't like this graph, yeah.
Do you have the, on your little keyboard, choice of functions?
Oh, okay, 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 here we go. Oh, wow, that's a funny graph. Oh, I see. Huh.
Isn't it a co-squared of x? No, y equals.
On the other side? Just graph the simple one and see what that one looks like.
Okay, so we're gonna take a look at the cotangent of x, sine of x divided by let me see. Cotangent of x, sine of x divided by the secant of x. Okay. Now it looks like when you look at this, there's no asymptote. No asymptote.
So does that mean there's no non-permissible values?
So that means there's no non-permissible values.
Is that
Let's
because
go
it's
pi.
one?
Let's go pi k. It's at 1. Okay, and now let's go back to this.
And we try the other one.
Okay. So when we look at this one here, the sine of x, they cancel each other out. So that gets rid of that non-permissible value there. And then the cos of x, when we had to take the reciprocal, this becomes cos squared of x. So there's no more denominator. So they cancel out all of the non-permissible value, then there's no non-permissible value.
Let me see the graph for.
Now let's take a look at letter C. Okay, let's take a look at letter C. Okay. So we're going to graph secant of x divided by cosecant of x. Let's see here. So these ones are going to have a non-permissible values at pi halves,
That's because it's the 10.
and 3 pi halves, 5 pi halves, negative pi halves. Yeah, because it's 10 and the tangent. It makes sense for us. I'm going to search it back, go back to this, because that will make, so you can see here, well, nothing cancels, but there's still a cos of x that still remains in this expression. So that one is still good. Yeah. So it's nice to have our graph kind of supporting us with trying to figure out our non-permissible values. Okay.
So what is the big one? Is this a question of like remember some knowledge or
Which one? For D?
Question A, we had a cancellation.
For A. Okay, let's take a look at, oh yeah, I was just going to show you what letter A looks like, right? So I'm going to show you in Desmos what A looks like. Cosecant of x. Okay, it doesn't like it when I don't use brackets. Secant of x. Oh, okay. We said it's equal to 1. and then this is 1. So no matter what angle we pick, it's going to be always equal to 1. So if that's the case, there's no asymptote. No asymptote. So we're going to fix that one.
So when there's a cancellation, then we can assume
Yeah,
there's
we can,
no asymptote.
yeah, when there's no cancellation there, non-permissible values for cos. So that. So overall, non-permissible value. Okay, let's take a look at the next one.
I think it's when we get cancelled and then like symptom might be like a fault, right? Because that's what we used to do when they get cancelled and there is a fault.
There's a hole, yeah.
That's what we're learning.
With the polynomial function, yes. Yeah.
Is there kind of like similar, right?
So when we look at this one here, so there would still be non-permissible value, but there's a hole. No asymptote, but there's a hole. That's what you're saying, yeah. Yeah, we could say that way. It's still non-permissible value, but it's a hole. But when we look at this part here,
Maybe because just one graph, there is no like a fault.
there's no,
Because the waves cancel each other out.
because the waves cancel each other out. Okay. I'll look at a different explanation of that later on, probably tomorrow. Okay, but for now we'll do the proving of identities, and then we'll take a look at the cancellations later on.
Because this one too is a cancellation.
Because this one here, it seems like they're going to cancel, and there's going to be no non-permissible values for every single one of them, if it just so happens that way.
But the only one that wouldn't is the tan, but we know that because it's signed over codes.
Yeah, yeah. Okay, so right now we're going to do the identities, and then we'll do the non-permissible values later, tomorrow.
You want writing like instead of saying y equals 2, and you're writing like a root equation.
Which one?
For example,
Which one?
instead of writing y, if you say that it's plus 1.
The equation contains fine detail that has been fully resolved.
Yeah, because then the B2 there doesn't look like there's asymptotes.
Yeah. Yeah. Okay, so we'll come back to that one, but for now, we'll do the simplifying first, and then we'll go on from there. Okay?